Okay, we're going to be doing section 5.4, sum and difference formulas. So the first thing we need to do is write all these formulas down, and then you need to know where these formulas are so you can access them. Otherwise, this is not a possible section. So sine of u plus v is sine of u. So u and v are two different angles. Sine of u cosine of v plus cosine of u sine v. Sine of u minus v, sine u cosine v minus cosine u sine v. Cosine of u plus v, cosine u cosine v minus sine u sine v. And cosine of u minus v is cosine u cosine v plus sine u sine v. Tangent. Tangent of u plus v is tangent u plus tangent v divided by 1 minus tangent u tangent v. And tangent of u minus v is tangent of u minus tangent of v divided by 1 plus tangent u tangent v. Okay, so this is that front page is obviously very important because we have to make sure that we know where to find these and how to use them. That's the most important thing, is how to use them. What the point of sum and difference formulas are is that we need to find exact values of trig functions at angles that are not easily available on the unit circle, like 75 degrees, for example. What we want to do is use two angles that we know from the unit circle to either add or subtract to get the 75 in this case. So I'm going to use 30 and 45 because I know that those are both readily available and they add to 75. So if I'm following all those formulas up above, the 30 is the u and the 45 is the v. So now this is a cosine u plus v equation. So I'm going to follow the equation up above. You guys can reference that. So this would be cosine of 30 times cosine of 45 minus sine of 30 sine of 45. And then I need my unit circle to look at each of those individual values. Cosine of 30 is the square root of 3 over 2. Cosine of 45 is the square root of 2 over 2. Sine of 30 is 1/2. Sine of 45 is the square root of 2 over 2. So this is the square root of 6 over 4 minus the square root of 2 over 4. And we can combine that into one fraction. That's how I'm going to prefer your answers. Just like that. All right. Now let's deal with some radian measure. We have pi over 12. So we need to figure out if you prefer to work in degrees. I'm not going to be upset if you go ahead and turn this to a degree angle. I think that's probably actually easier. But if we're going to leave it as a fraction and we want to deal with our radian angles instead of our degree angles just for some practice, this is the same thing as pi over 3 minus the pi over 4. So let's use that for our difference angle in this case, sine of pi over 3 minus the pi over 4. And following the equation from the previous page, this would be sine of pi over 3 cosine of pi over 4 minus cosine pi over 3 sine pi over 4. And then from the unit circle, I plug in all of the corresponding values. Sine of pi over 3 is the square root of 3 over 2. Cosine of pi over 4 is the square root of 2 over 2. Cosine of pi over 3 is 1/2. And sine of pi over 4 is the square root of 2 over 2. This actually ends up being the same as our last question. Square root of 6 minus the square root of 2 over 4. Find the exact value of sine of u plus v given sine of u and cosine of v. So looking at all those sum and difference formulas, I need to have the sine and cosine of both angles before I can do this. So I'm given sine of u, which means I need to find cosine of u. And I have cosine of v, which means I need sine of v. So I always need both. Sine of u is in the first quadrant. It's between 0 and pi over 2. And sine is r, it's y over r, which means we need to find the x value. This is, in fact, a perfect, or a Pythagorean triple. So our x value is 3. If you don't recognize that, you could always solve for x using the r equals the square root of x squared plus y squared formula. I'm essentially doing that in my head. Cosine is 3 over 5. And if we're between pi over 2 and pi for angle V, that's in quadrant 2, sine is going to be positive there. And the third side of this triangle is 5. It's another Pythagorean triple. So this should be 5 over 13. That might take you a couple more steps to figure out other than doing it in your head, but you can always use the r equals square root of x squared plus y squared to find your answers. So now we have all 4 of our trig functions that we need, and we're going to do sine of u plus v, yeah. So following my equation, sine u, cosine v, plus cosine u, sine v. And now we have all 4 of those, so we can plug them in where they belong. So this is 4/5. Cosine of u is negative 12/13, or cosine v, I'm sorry. Cosine of u is 3/5, and sine of v is 5/13. So we have negative 48/65. Whoops. Plus 15/65, which ends up being negative 33/65. All right. We're actually going to skip this one, so yay for that. We don't do a whole lot with arc tangents and arc cosine, so we'll be fine with not doing that. But we are going to do this one, prove the cofunction identity. So this is on the that first page of, I believe it's just section 1 of this chapter, where it has all of the different Pythagorean identities. There's something called cofunction identities as well. And this is one of them, cosine of pi over 2 minus x equals sine. And we're going to look at this like the difference formula, cosine of u minus v. So now we're going to apply the formula for cosine of u minus v for the above, cosine of pi over 2 minus x. So this would be cosine of pi over 2, cosine of x, plus sine of pi over 2, sine x. Okay, so cosine of pi over 2 is 0, and sine of pi over 2 is 1, which is handy because we wanted that first term to go away. We wanted to end up with just sine of x, and we did, so we are done with that one. Simplify each expression. So we're going to do the same thing, only we're not trying to prove anything. We're just going to use our difference formula with theta being our u and 3 pi over 2 being our v. Cosine theta, cosine 3 pi over 2, plus sine theta, sine 3 pi over 2. And then I can plug in values for sine of 3 pi over 2 and cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0, and sine of 3 pi over 2 is negative 1. So this term, whole thing simplifies to negative sine theta. We have a sum formula and it's tangent, so we get to the opportunity to use one of these tangent equations. This would be tangent theta plus tangent 3 pi over 1 minus tangent theta, tangent 3 pi. So 3 pi on the unit circle is the same thing as pi, so we're going to be looking at pi to find the tangent value. Tangent of pi then is 0. So we plug that in both places, and it simplifies just to tangent. Find all the solutions in the interval. So this we're going to bank off of section 3, where we solved for the trig functions on the unit circle. Only this time we need to simplify it using the sum and difference formulas before we can use our section 3 knowledge. So you have to use the sum formula and the difference formula, so we'll do both of those right away. Okay, so this is the sum formula, and this is my difference formula. So now you want to combine any like terms that I have, and I have those two terms are opposite, so they go away. And then those two terms are exactly the same, my other two, so they can add to 2 sine x cosine pi over 4. And cosine pi over 4 is a value, so we can figure out that too. So the 2's cancel. We have the square root of 2 sine x equals -1. So sine x equals -1 over the square root of 2. Okay. Our x value would be 5 pi over 4 and 7 pi over 4. Straight from the unit circle. And since it says in the interval from 0 to 2 pi, we do not have to add on the 2n pi. And the last thing we're going to do, so a lot of you are bound for calculus, so this is an example of how, of what we would do in calculus. This is called the difference quotient. So what we're going to do, we're trying to prove right now, we're just trying to prove that the left side is equal to the right side. So the only thing that we know how to do so far is, hey, we have a sum formula here that we can do. So that's the only thing we're really going to elaborate on, and then we're going to try to equate the left to the right side. So this would be sine of x cosine of h plus cosine of x sine h minus the sine x that was already there divided by the h that was already there. So now I'm just trying to see how I can make that what I have now look like the right side. So I have two terms that have sine in them. So now what I'm going to do is I'll leave the first term alone and then take a sine x out. If I do that, 1 minus cosine h is what I have left on top from pulling out the sine. And then I can turn that sine over sine of h over h right here. I can break this up into two terms now. Okay, so this was just a little bit of rearranging, but the only thing that we did was use the sum formula. Okay, so I actually did right there just rearrange it a little bit to make it look like the right side. Scroll down, look at your homework, and that is it for section 4, sum and difference formulas.